on to actually doing things with complex numbers, we're going to first do add, subtract, and multiply. Divide will get a different video. So add and subtract, super simple. Only thing to really remember when you're adding or subtracting complex numbers is like terms. We're going to combine like terms just like as if the i's were variables. So we'll do a couple examples. If I have this complex number plus this complex number, if that's my problem, that's my question, and I'm asked to add those, then I'm just going to add my 5 and my 3 and my negative 2i and my positive 7i. So I got 8 plus 5i. Super simple. If I'm subtracting, I got to take that one extra little precautionary step in that if I'm subtracting, if I have 2 plus I and I'm subtracting, this complex number, it's got two parts that each have their own sign. So we're going to change the sign of both of those. If that's my question, my first step is going to be, after I recopy it, because these are my notes, and I want to know what the thing looked like in my notes before I start messing with it, the first thing I'm going to do is cross the line, change the sign. So my 6 became a negative 6 plus negative 6, and my minus a negative 3 became a positive 3. So now I'm going to combine my like terms just like I did on the other one. I'm going to group them together. Those are my two real terms. And then those are my two imaginary terms written next to each other. So I've got my real part is negative 4, and my imaginary part is positive 4. Just like in other cases, if that doesn't have anything in front of it, it's a 1. So hopefully those two are very straightforward. Multiplying takes one little extra rule. You got to remember, you can never leave an I squared. Remember, when we talked about standard form, we never said anything about I squared because I squared doesn't have to be part of our answer. So if I have 3 times 5i, well, this one isn't going to have any I squared as part of my answer because it's just going to be 15i. I can't really say anything more than that. 3 times 5 is 15. The I just comes along. There's nothing to times the I with. But if I have, say, 6i times 2i, well, now I've got 6 times 2 and I've got I times I, right? Those are, I guess I could have done an intermediate step on the last one. I've got 12 times I squared. Well, what's I squared? I squared is just negative 1. So anytime you have an I squared, you're going to replace it with negative 1. So my answer is negative 12. Okay, so I'm going to pop back up here and replace it with negative 1. Super important. This time we'll actually do a real times a complex. Last time we did a real times an imaginary and a real, or imaginary times imaginary. Now we've got a real times a complex. Right, 5 is real, 2 plus 4i is complex. If I'm going to do that, again, I'm just going to distribute 5 times 2 plus 5 times 4i. Not a huge deal. Real part, imaginary part. But what if I'm distributing an imaginary number? 8i times 3 minus 7i. So this time when I distribute, I've got 8i times 3 plus 8i times negative 7i. So now I've got this imaginary term in front, 8i times 3. Make sure we know that's an I. And then I've got negative 56i squared. Well, we said we can never leave that I squared as an I squared. We're going to replace it with negative 1. So I've got 24i minus 56 times negative 1. I know I'm just repeating that, but I want to make it very clear what I'm doing. So that's positive 56. So in order to write this in standard form, we need the real part first. That's positive. My imaginary part is also positive, so plus 24i. If my imaginary part was negative, that would turn into a minus. So there's an example again of we don't want to have an I squared in our answer. We're going to have I squared getting replaced by negative 1 and doing that multiplication. Okay, now we've got two complex numbers. So, well, if these were both just binomials with x's, how would I do that? I would do that using the box. If you like FOIL, works just the same, but I'm going to use the box. So I've got 5 plus I one way and 2 minus 3i the other way. 5 times 2 is 10. 2 times I is positive 2i. 5 times negative 3i is negative 15i. And I times negative 3i is negative 3i squared. So when we do the box, because we're always going to be using standard form, these guys are still going to get combined just like they would if we had a trinomial with x's and stuff. So we have 10. I'm going to write them all out just so you see. So it looks like a trinomial, but we're not going to put the squared thing in front. We're going to combine those like terms in the middle. What am I going to replace I squared with? Negative 1. So 10 minus 13i plus 3. So again, I'm just going to gather my like terms. I'm doing this in more steps than I would if I were actually doing it on my own. I just want to make sure you know where everything is coming from. I just moved my like terms together to gather them, so it's 13 minus 13i. So make sure that you can see they're not always going to be the same number. That's just a coincidence on this one.